like the drive to do it.
Okay, just come in, wake up in the morning to come.
Yeah, and like all that stuff. Because for me, like I just think like okay, if I'm not gonna come to tuition, I'm just gonna be on my phone, right? So
Yeah. Well, it's 1 second. Let me go back to my Zoom. So I'm just going back to share iPad. Share. That should be. Let me to just share this. Tell me in what screen you're seeing it.
it still says screen.
Okay, why don't you just lower it? Okay. So I'm gonna going back to us to say that in the last class we started to work on tricks. So logarithm, and then we will finish logarithm and come back to rational functions, and then you share your tests on exams on 29th.
Yeah, I'm on this.
Okay, so we have another maybe to do on us that you just want to come on that next Saturday to make it just invite you guys.
I can come Saturday too.
That's Saturday.
Yeah.
Okay, so I can keep that beat. That's perfectly fine. All right, so let's going back to the graphing part of logarithmic functions. So the first graphing part is drawing the exponential function. So y is equal to 3 to the power of x. So when you come to graphing, all you're going to do is you're just going to be going back to, there's several ways to do, just we're going to use the mapping notation. So we want to draw the graph of first y is equal to 2 to the power of x. So I'm going to choose some points. So I'm going to choose points, some of the points is going to be in positive and negative direction. So this is x, this is y. So I would choose -2, -1, 0, 1, 2. So if I choose -2, this is going to be 2 to the power of -2. There's 1 over 2 to the power of 2, 1 over 4. That's around 0.25, isn't it? Okay. This point is going to be 2 to the power of -1 is 1 over 2, which is going to be 0.5. This is 2 to the power of 0 is going to be 1. This is 2 to the power of 2, 2 to the power of 2 is going to be 4. Now, we look at the transformation. We need to draw the graph for y is equal to 3 times 2 to the power of x. Well, this 3 only going to be affect my y value, nothing else. So I can able to just go back, keep the same x values, not changing on x value, -2, -1, 0, 1, 2, multiply all of them by 0.75. This is going to be 1.5. This is going to be 3. This is going to be 6. This is going to be 12. So
wait, why is it 0.75?
This is 0.25 times it by 3, right? 3
Oh.
times 2x.
Yeah.
So I'm applying the mapping notation. So what I'm going to do to show how the graph will look like, we're going to be actually draw both graphs, the parent graph and then also the transform graph, so that we can clearly see the picture. So this is going to be some scales here. So -2, this is -1, 0, this is 1, this is 2, this is 3, this is 4. All right, so -2. And then when we have -2, this is 1, and this is 2, this is 3, this is 4. Well, you can see that I need to really change that y scale a little longer because I can go up to 12. So what I'm going to do, I have an option to change this one back to 0.5 So 2, 4, 6, 8. Let me just check that part out to keep that as 12. That is going to be 10. So I don't have the 12, that's fine. So first point, we got our ordinal parent function, you got -2.25. So -2.25 is going to be somewhere here, isn't it? -2.25. This is going to be -2, this is going to be 0.25 half here. So this is the first point. Then I got -1.5. So that's going to be this point. Then I got 0, 1. So 0, 1 is going to be, I think that I'm not correct because I go by, hold on. Did I go by scale 2? Yes, so this is 1, right? So if this is 1, my first point -2.25, that's going to become very close here. Then -1.5 is just going to be middle of that. And then this is going to be my next point. And then 1 is going to be 2, and then 2 is going to be 4. So technically speaking, my first graph will go like this, isn't it? Yeah. So this is just a give. I know 3 is going to be 2 to the power 3 is going to be 8, so it's going to turn like this. Okay. Now let's plug these ones. So the first point -2.75. So if you have -2.75, it's just going to go a little up. So let's choose the different point. So a little up. Then I got minus 1.5. So minus 1.5 is just going to be that. Then you got 1 with the 6, and then 2 with the 12, just going to go here. So now the graph is going to be like this, isn't it? So now you can see the shape of the curve. This is called vertical stretch by a factor of 3. So every point is stretched up vertically. So you can see that it's stretched up, right? Another way to draw it, we can actually count 3 points to move this point. For example, this is 1. My original point is going to be, you can say 1, isn't it? So 1 is going to be triple. So it's going to be 1, 2, 3. And if I go back to this point, this is 2, 2 triple. So 2 triple is going to be 2, 4, 6.
Oh, yeah.
You can also do that from the parent function without using the mapping notation. So let's moving back to the next curve, minus 2 to the power of, and y is equal to, so the next curve, y is equal to minus 2, and then power of 3x. So this one, we just need to be careful what kind of transformation is going to happen. It's very important to understand the transformation. So there's a minus here. This is stand for the vertical reflection, isn't it? Or we're going to say reflection on not vertical reflection, reflection on the x-axis. Reflection on the x-axis. What is this transformation is going to do? This is responsible for the horizontal. So when it's 3, we're going to solve horizontal compression. Horizontal compression by a factor of 1/3. Well, we can go back to our table of values again to just draw the graph. So if I going back to my table of value for x and y, so this is the x values or y values, so we start minus 2, minus 1, 0, 1, 2. Minus 2 is going to be minus 2 to the power of 2. So we're drawing y is equal to 2 to the power of x. So that is going to be 1/4, it's going to be 0.25. And then it's going to be 1/2, which is 0.5. So why did I do that? Parent function, 2 to the power of minus 2, 1/2 to the power of 2, 1/4. This is again parent function, 2 to the power of minus 1, so 1/2, which is 0.5. This is 2 to the power of 0, which is 1, 2 to the power of 1, which is 2, 2 to the power of 2, which is 4. Now let's go back to the mapping notation. That's the key. So just recall when a function f of x is going to be go through, so just going to do a little darker pen. So when a function f of x is going through the following transformation, a into f k x minus d plus c. If you have a coordinate x comma y, this coordinate is going to be switched back to x over k plus d comma ay plus c. So in this example, we're going to looking at what's going to happen. So in this example, my a is minus 1, my k is 3, d is 0, c is 0, isn't it? So if I have a point x comma y, it's going to be x over k. So it's going to be x over k is 3 plus d is 0, ay minus y plus c is 0, isn't it? So let's generate this new points from this original point. So this is x, this is y. So minus 2 is going to be minus 2/3. 1/y is going to be minus 1/4. Minus 1 is going to be minus 1/3. And then this one is minus 0.5. 0 is going to be just 0. This is going to be minus 1. And 1 is going to be 1/3. And then 2 is going to be minus 2. And then 2 is going to be 2/3. And then here, 4 is going to be minus 4, isn't it? Well, even though these points are fractions, we should be able to just scale it nicely, just as 2/3 minus 1/3, 1/3. So what would I do on my graph? I would choose a scale that's fit that to draw it. So there's an option for me. You can see that all the scales on the x is pointing by minus 1/3. So what I will do to keep this nice, so this is going to be minus 1/3. This is minus 2/3. This is minus 1. Make sense? This is going to be positive 1/3. This is going to be 2/3. This is going to be 1. Because those are the points I got, isn't it?
Yeah.
Now I can see that these points are going back, this is minus 0.25. Well, to get the shape of the picture, we have a choice, we can go back to 1. So that should be able to give me the points I'm looking for, 2 and 3. Or we can just scale it back. So let's go back to the first point, minus 2/3, 0.25. So to make the graph look nicer, I will also choose my scale nicely because I need to go up to -4. So let's going back to 1 here. Okay. So we can go back to scale by 1 here. This is my 2, this is my 3, this is my 4. And this is going to be -1, this is -2, this is -3, this is -4, isn't it? So first point, minus 2/3, minus 2/3, minus 0.25. So that's going to be minus 2/3, minus 0.25, minus 0.5. So you're in the middle of here. The next point, minus 1/3, comma, minus 0.5. So minus 1/3. Let me go back again to the point I marked. So this point is minus 0.5. This point is going to be minus 0.25. So first point, minus 2/3, comma, minus 0.25 is going to come over here. The next one, minus 1/3, comma, 0.5, this is going to come over here. 0, comma, minus 1 is going to come over here. 1/3, comma, minus 2 is going to become over here. 2/3, comma, minus 4 is just going to become over here, isn't it? So how's my curve is going to look like? The curve is going to look like that. See that? Yeah. All right, so that's basically my second graph. All right, okay, so we're gonna go back to the third one. I'm gonna say third one for you to practice because I would like to leave one question for you guys to practice so that you can apply the transformation to draw C, which is basically pretty straightforward. Y is equal to minus 2 to the power of minus x plus 4. So I can have a quick sketch. If you have y is equal to 2 to the power of minus x, this is that 2 to the power of x curve, right? This is going to be a reflection on the y-axis. So that's going to be a reflection on the y-axis. It will take the same symmetric shape like this, right? Then what you're doing is you're moving this one up. So 1 will go to 1 plus 4, 5 here. All it's going to do, same curve is going to go something like this. So that is pretty straightforward transformation, isn't it? You can see that's sitting on the top. All right, now we're going to going back to graphing the log functions. So let's going back to graphing the log functions, number 2. So graphing. If you have a questions, guys, you can ask. Graphing logarithmic function. All right, so the first logarithmic function that we have to draw is logarithmic functions. Log, okay. We need to draw y is equal to minus log x plus 2. Now, something that you need to be careful when you're drawing logarithmic functions, the base. So when there's no base specified, by default is base 10. So I'm going to create a table of values. So let's go back to create some table of values to draw it. So every logarithmic function is not defined when the parameter here is going to be negative, isn't it? Actually 0. So x cannot be 0. So that means in this location, we're going to have vertical asymptote. Make sense? So we will have a vertical asymptote because this cannot be 0. And also, this cannot be taking negative values. So the x must be greater than 0. So I am going back to plug some point, x and y. So we're going to be just going back to some points that are easy to deal with. So let's start from the point when x is 1, right? And then I'm going to go back to x is 10, which is easy to find out. The question is, can I able to go back to the next point? So that's what a little trick. So what I'm going to do, I'm just going to keep one other point is pretty easy, 1 over 10. Okay, then I will go back to 1. Then I'm going back to 10. So if you do log base 10, 1 over 10, you can rewrite log 10 to the power of minus 1. So it's going to give you minus 1. And log 1 with base 10 is going to be 0 because 10 to the power of 0 is going to be, this is going to be 0. And then this is going to be given us 1. So let's have a rough sketch about the log function using that. So how the log function is going to look like first. So I said choose the point that's 1/10. So this is going to be, let's see, this is going to be my 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8, 9, 10. So we got 1/10 supposed to be -1. So this is -1. So 1/10 is going to be very close here. So it's going to start from here, isn't it? 1 is going to be 0. So that's going to be next point. And then 10 is going to be 1. So 10 is going to be 1 here. So my log function is supposed to be go like this, isn't it? And then you can see there's a vertical asymptote at x equal to 0. Now what we need to do, we need to do minus logs plus 2. We can use the same point to graph it. So we're going to do the transformation. So what the transformation does is only going to be affect my y value because this is a and this. So let's generate a new y value for the same x values. 1/10, 1, 10. So all I need to do is I'm going to be just multiply this one by minus. So positive 1, 1 plus 2 is 3. 0 times -1 is going to be 0. 0 plus 2 is 2. And 1 times -1 is going to be -1 plus 2 is going to be positive 1. So when I have 1/10, it's going to go to 3. 1, 2, 3, isn't it? So it's going to be going back to 1, 2, 3. Okay. Then at 1, I got 2. At 1, I got 2. And then 10, I got 1, isn't it? 10, I got 1. But something that we should also know, this particular function, it is going to be reflected on the x-axis. So you can see based on the points, it start here. The only thing is going to be go the other way around. So how well possible? For sure, it has the same vertical asymptote. Now just going back here. You go to that point, isn't it? You can see the shape of the curve. So that is basically the logarithm function curve. You can see it. So it's some of the key points. So there's a couple more functions on that to play around. I really want you guys to practice the B and C, right? Same idea. The key is the transformation, all of them with the base 10. So this is pretty easy to draw. This is horizontally translate to the left by 4 unit. So when you want to do y is equal to log, x plus 4, pretty easy. All I need to do is I need to move all these points that I generated to the right by 4 unit. So this point is going to move to right to the 4 unit. So what will happen? This is going to go 1, 2, 3, 4 units is going to come over here, right? And then the point I choose is going to move 4 units to the right. So you need to do, what is the point I got? -1. -1 plus 4 is? -1 minus 4 is -5, isn't it? So where that point will go, it's going to go back to, hold on. So 1 second. So we can simply move the whole graph right by 4 unit. So this one once you move to the 4 unit, we are 10. To make sure that we're in the right. So let's make a right thing with the log x plus 4, probably will move on to the left, so that's the yeah, so this point is going to move 4 units, isn't it? 1, 2, 3, 4 units. It's going to come over here. You saw that? And then there's a one more point I need to do. If I move it, it's going to have an asymptote at -4. So let's put that -4 as the asymptote, right? And at that point is going to come over here. So what's going to happen? This is going to be go like this, isn't it? Do you see the shape of the curve? Yeah. All right. So we started to do some review. Just going to be a little pause here. So stop sharing. And